So in this video, we're going to be describing transformations for a quadratic function when given its equation. So before we jump in and we analyze different equations, I want to review what we've already learned about transformations previously in Algebra 2. So what you should already be familiar with are horizontal and vertical translations, and those are the movements where we move the graph left, right, up, and down. And you should already know at this point that if you add a value to the inside of the parentheses with x, which we can see here. If we add a value inside of those parentheses, it's going to move the graph left or right. And remember, with horizontal translations, these work the opposite of what we expect. Then you should also know that if you add a value on the outside of the parentheses, so out here as k, that is going to move the graph up or down. And it moves as we expect it to. So if we add 2, we go up 2. If we subtract 3, we go down 3. So remembering these translation notes that we took in a previous lesson. Now, in addition to translations, we also studied reflections and horizontal stretches and shrinks. So a couple of things to remember here. One, remember that these vertical reflections, where we reflect the x-axis, that multiplied the outside of the parentheses by -1. And then the reflection of the y-axis, which was that horizontal reflection, that multiplied the x value on the inside by -1. So remembering those reflection notes. In addition, our vertical stretches and shrinks works just as expected on the outside. So here we multiplied the outside by our a value, and that vertically stretched our graph if the absolute value of a was more than 1, and it vertically shrunk our graph if the absolute value of a was less than 1 and greater than 0. So here is our stretch, and here is our shrink. Then from here, the only thing that's going to be a little bit confusing for us is going to be this b value, or our horizontal stretches and shrinks. So you should remember from our previous notes that those horizontal stretches and shrinks used 1 over our b value, or the reciprocal of our b value. So if they tell us that we have a horizontal stretch of 5, what we're going to do is we're going to take our b value of 1/5, and we're going to multiply our x value on the inside by that value. So now as we interpret these different equations that we have, we're going to have to work backwards with that mindset. What we're going to see in our equation is the b value, and we'll have to take that b value out, change it to its reciprocal, and that will tell us whether or not our graph stretches or shrinks. Now, what you need to be careful of when you're interpreting our b value in here is you have to remember that we're flipping b to its reciprocal to figure out if we're stretching or shrinking. So if you focus just on the b value here, b actually works opposite of a. This is why we typically flip it to its reciprocal, and that allows us to really see what's going on. But if you have a b value that is, say, 2, if your b value on the inside of your parentheses is 2, then you're going to have to flip that to 1 over 2 to figure out that this is in fact a shrink. So notice here, b value equal to 2 produces a shrink because it becomes 1 over 2. So we'll talk about that as we go, but just being very careful about how we interpret these equations, especially when it comes to horizontal stretches and shrinks. So let's jump on in and start a couple of examples. So here, if we look in our first function, we're looking at the numbers that they've added in beyond just the x. So here I see a -2, I also see a -3. So we have to think about what those values represent and how they're going to transform that parent function. So here let's go ahead and start with this -2 value here. And if I look at the location of -2, I notice it's being multiplied out in front. So I know that my a value here is equal to -2. So if I think about what this value is actually going to do to my graph, first, I'm going to focus on the negative part, and that negative part is going to make it reflect or vertically flip. And because it's a vertical flip, if I think about that, that's a reflection over the x-axis. So we can say reflection or reflect in the or over the x-axis. So that's what's first going to happen because of that negative. Then the 2 part, when a is equal to 2, a is going to make that graph 2 times as tall. And as a result, we have a vertical stretch. Now from here, if we take a look at the -3, that -3 is associated with h. Now, I'm not going to put h equals -3 here because I know h deals with the -3. But what's really going to happen here is that h works the opposite of what we expect it to. So, h works the opposite of what we expect it to. Since this is a horizontal movement left and right and it works the opposite of what we expect it to, that -3 tells us that the graph is going to move right 3 units. So it's going to move in the positive direction. So if you're using the notes from the book, h here is really equal to a +3 because that positive movement moves it to the right. So we have 3 different transformations taking place here. We have a reflection in the x-axis from the negative out in front, a vertical stretch by a factor of 2 from the 2, and we move right 3 units as a result of this -3 in here. So now if we move on to question number 2 and we take a look, we notice that we have a 4 being multiplied, but this time it's on the inside, and we have a 5 being added to the outside. So we have some different transformations going on here. If I start with the 4, I know that my b value is equal to 4 to start. But I also have to keep in mind that my b value isn't necessarily my horizontal stretch or shrink factor. Instead, I have to think, okay, well, if my b value is equal to 4, that means that my horizontal stretch or shrink factor is the reciprocal of that, which is 1/4. So because b is equal to 4 and I flip it to its reciprocal, here I can see that I have a horizontal shrink by a factor of 1/4. So that's what that 4 does, is it horizontally shrinks the graph by a factor of 1/4. Then from here, if I take a look at this +5 on the outside, that +5 represents my k value. And as a result of that k value, I know that this is an up and down movement. So I know as a result that my graph is going to move up, because it works as expected, 5 units. So in this problem, I also have a couple different transformations going on. I can see that I have a horizontal shrink as well as a movement up 5. So let's take a look at 2 more examples here. So here in example 3, I notice that I have 0.3, a +2, and a -4. So I have to think through what those values represent and what they're doing to that parent graph to transform it. So if I start with 0.3, I know that my a value is equal to 0.3 because that a value is multiplied out in front. Now, this isn't negative, so it's not going to flip or anything, but I do have to pay close attention to the fact that this has an a value of 0.3. And 0.3 is less than 1, but more than 0. So here what's going to happen is I'm going to have a vertical shrink because it's going to make the graph 0.3 times as tall, so it's going to take it down a little bit. It's a vertical shrink by a factor of 0.3. Then if I move on to this +2 here, I know that the +2 relates to my h value. So my h value, it's related to that +2, but I have to think about this one a little bit because h values work the opposite of what we expect. So here I'm really going to be moving to the left. So I'm going to move the opposite of what I expect, move left 2 units. So my h value here is really a -2 because it's the opposite of what I expect, and it's moving to the left 2 units. Then that last value here deals with my k value because it's being added on to the end. So I have a k value that's equal to -4, and those values that are being added on the outside move the graph up and down. So this k value of -4 is going to move the graph down 4 units. So you can see our 3 transformations there from our 3 values. Now, in example 4, we notice that there's only one thing and one number here on the inside, but with that negative, there are actually 2 different things taking place. So here, I'm going to start by focusing in on this negative here. Because we have a negative on the inside, what that's telling us is that we have what's called a reflection, but it's a horizontal reflection. So remember, anything on the inside of these parentheses is going to be a horizontal change of some sort. So that negative on the outside tells us that we're going to have a horizontal reflection. And if we think about that, how we have a horizontal reflection is we reflect over, or in math we say reflect in the y-axis. So we're going to reflect over that y-axis in order to have that reflection that is a horizontal reflection. Then from here, I also note that I have a b value because it's being multiplied by x on the inside. My b value is equal to 2/5. But remember, our b value doesn't actually tell us what our horizontal stretch or shrink actually is. What we have to do is we have to transform it to its reciprocal. So we flip it over, and we find that we have 5/2, which, if you're multiplying that out in your head, is about 2.5. So what that's telling me is that this b value of 2/5 is going to horizontally stretch our graph by a factor of 2.5 because this 2.5 value is bigger than 1. So here we have two different transformations taking place. We have a reflection about the y-axis, and we have a horizontally stretched graph by a factor of 2.5. And last but not least, let's take a look at a couple of larger problems on this one. So here, let's start in example 5 with this -3/8. I see that that is my a value. My a value is equal to -3/8. And we know that that negative value here is going to be a vertical flip of the graph. So if we think about which axis we're flipping over, that's going to be a reflection in the x-axis because that's how we vertically flip. Then that 3/8 is less than 1, so that particular value is going to vertically shrink the graph by a factor of 3/8. So it's going to make it 3/8 as tall. So it's going to vertically shrink by a factor of 3/8. Then if I move on and I look at this value here, this -6, I know that this -6 relates to my h value. And remember that my h value works the opposite of the value that's in the problem. So here my h value is really going to be a +6 because it's going to move the graph to the right 6 units. And then last but not least, out here on the outside, we have our k value. And our k value here is equal to 2. And as a result of that, that is our vertical movement. So we're going to move the graph up 2 units. Then from here, if we look at example 6, and we start with this negative out in front, this negative out in front is still a part of our a value. This is really an a value equal to -1. So as a result of that, we have another reflection about the x-axis because that's going to be a vertical flip. Then if we move on the inside here, we have a b value that is equal to 8/3. And remember that in order to use that value, we need to flip it to its reciprocal, which is 3/8. So here we have a b value that tells us that we have a horizontal shrink because 3/8 is less than 1. So we have a horizontal shrink by a factor of 3/8. Then next we notice that we have this +6 on the inside, and we know that our h value is related to that 6. As a result, we look and we think, okay, h works the opposite of what we expect, so this graph is going to move left 6, which makes our h value -6. So we're going to move to the left -6. Then from here, we have our k value on the outside, so k is equal to -5. That's going to move our graph down 5 units. And I should have put 6 here as well. So while there's a lot of transformations going on here, as long as we know A, B, H, and K and how they impact our equations, we can identify and describe all of the transformations from that parent graph to create that child graph.